Two childhood fascinations, dinosaurs and mummies, collide in one of the rarest fossils ever discovered: dinosaur mummies. Now, you may be thinking of a T-Rex wrapped in linen cloth, surrounded by gold in a pyramid. But dinosaur mummies are not like typical mummies. Replace linen with its own skin, gold with sediments, and a pyramid with rock. We're going to show you some of the best preserved dinosaur fossils ever found and explain how they've helped us understand what dinosaurs truly looked like. Hi, I'm Danielle Dufault, and you're watching Animalogic. Usually, fossilization only preserves the tough stuff. Bones, teeth, and shells get buried and slowly replaced with minerals, leaving behind a stone copy. But dinosaur mummies break the rules. These fossils have soft tissues preserved, so things like skin, scales, and sometimes even internal organs survived against the odds. Meet AMNH 5060, named the AMNH mummy, the first dinosaur mummy ever discovered. It's an Edmontosaurus, one of my favorite duck-billed dinosaurs that roamed the Earth 73 million years ago. When scientists uncovered it, they found the dinosaur lying on its back, forelimbs stretched wide, and its neck twisted upwards, like it had struggled, taken a final breath, and then sat still. To any other dinosaurs nearby, it may have looked like one of their own had simply laid down for a nap and never gotten back up. Its bones were still fully connected, preserving the exact position of its body in its final moments. Let's take a look. Edmontosaurus, such a classic duck-billed dinosaur. It's a name that's probably like the first duck-billed dinosaur that you'll hear of is going to be Edmontosaurus because we have so many specimens collected and it's been part of the literature for a long, long time. But somehow, this considered standard duck-billed dinosaur keeps on throwing more and more curveballs, and I love it for that, I really do. So we have this incredible mummy called the AMNH 5060, and it is a mummy in the true sense of the word. It's got skin just preserved all over its body from different areas, which is really interesting. I'm looking around at the photos right now from the original publication, and they did such a lovely job of tracing out all of the little tubercles, so every little scale piece individually. And it kind of helps you pick up an idea of, you know, how its skin could have looked laid out on different parts of its body. Because this clearly indicates that, you know, those scale tubercles were not the same size all over. So there's new research coming out based on this specimen constantly. Well, constantly, every couple years, let's say. And one of the most interesting recent things to come from it was talking about this skin frill that's going down its back. And that's really cool because we didn't really know that Edmontosaurus had this. It's got these different shaped scales that are kind of imbricated, a little bit like other duck-billed dinosaurs that maybe we'll talk about later. But yeah, seeing its entire body preserved like this and getting a glimpse at the external anatomy of every part of its body, that's an absolute treasure. Edmontosaurus, nothing standard about ya. All of these details give us clues about the precise conditions needed for such a fossil to exist. Paleontologists think that the AMNH mummy possibly died during a drought, maybe due to starvation. The shrunken skin wrapped tightly around its bones is something we still see in today's animals, like lizards that die of starvation during droughts. Under intense heat, the AMNH mummy's body dried out fast, leaving behind a jerky-like vacuum seal around its body. Something else about the AMNH mummy that tells us how it died was that there were no signs of scavenging. Nobody ate it. This is unusual for such a large carcass, unless the environment itself was unusual. In extreme drought conditions, There may have been so many carcasses that scavengers literally couldn't keep up, allowing the AMNH mummy to dry up undisturbed and eventually become one of the best preserved dinosaur mummies ever found. Being in the wild out of our home country is amazing because you get to see so much unique wildlife you've never seen before. It can be tough to know what they are if you don't have access to the internet. But since I've been using a Saily eSIM, I can look them up on the spot, ID them, and learn all about them. For example, that. All we need to do is look it up online, and now we know everything about it. We just spotted a lizard on the rock over here, and from a distance here, we can't quite tell if it's a local species, so a native lizard species, or if it's the invasive Italian lizard variety, which are not encouraged to be around here. But now that we got a good shot of it, we can connect to the internet using Saily and go identify what kind of lizard we're dealing with here. It's pretty great having internet out here, I gotta say. And we learned all that thanks to Saily. Saily is an eSIM provider. That means that you download the app and you have access to the internet in over 200 places around the world. All you have to do is pick your destination, choose the plan that makes sense for you, and then download your eSIM. And that's it! You're now connected to the internet anywhere. The internet seems to think that it's a granite spiny lizard, which makes sense because they're endemic to this area. But we're going to take a look a little closer at the footage later tonight. You only have to download the app once, and it saves you the time and the hassle of buying SIM cards at your destination. It also automatically blocks ads to save data. And if you have any issues, they have a support team available 24/7 to answer your questions. Their plans are super affordable, but if you use our promo code, you can get them for even less. Go to saily.com/animalogic or click the link in the description and use code Animalogic to get 15% off. So when you're traveling, let us know what amazing new animals you saw. But how does a mummy become a fossil? For fossilization to happen, a body has to be buried, usually by sediment carried in by rushing water. Without that protection, microbes, scavengers, and the elements would quickly tear it apart. So, in the case of the AMNH mummy, scientists believe that there could have been a sudden flash flood that roared through after the drought, burying its dried, shriveled body under waves of sediment and locking it in the fossil record. Without the burial, there is no fossil. As water seeped into the ground, it rehydrated the mummy, slowly filling the empty spaces of the AMNH mummy with mineralized groundwater. This is when the really cool stuff began to happen. First, microbes began nibbling away at the remaining soft tissues, like tiny recyclers breaking things down piece by piece. At the same time, minerals slipped into those newly opened spaces, settling in like grains of sand in wet cement, until little by little, the dinosaur's body hardened and turned to stone. The reason why the fine details were so well preserved was that the dinosaur's body was mummified before burial. When this happens, decomposition takes even longer to happen, meaning the details can be protected long enough for the minerals to capture them. This gives us a fossil so well preserved that we can see structures down to the microscopic level. Hadrosaurs make up a large percentage of the dinosaur mummies found today. This may be because of their large population near sandy rivers, in combination with their tough and thick skin. Speaking of hadrosaurs, meet Dakota. Dakota was discovered in North Dakota in 1999 and shows even more detail than the AMNH mummy. Along its back and tail, you can see a series of small spikes or ridges in the skin, and even the keratinous coverings of its hooves. Wow, this Dakota, it tells such a story. Because not only do we have all of this incredible skin preservation and like three-dimensionality, but we also have evidence that, there were scavengers. It was being fed upon. And yeah, I'm just looking at those claw or tooth marks. those grooves that were cut into its skin. I mean, poor Dakota. Those scavengers actually helped preserve Dakota. By poking holes in the body, they let gases and fluids escape, speeding up the mummification process. It's kind of like when you poke holes in food packaging to let air out. Except, imagine that, but with dinosaurs, teeth, and absolutely no health inspector. Alright, I guess the first thing I gotta say here is that the arms and hands on AMNH 5060 are incredible, but they kind of pale in comparison to everything that Dakota here can show. I mean, Dakota is the first dinosaur to show us that duck-billed dinosaurs had real hooves. Their little nail beds, they supported a whole hoof that would, make it possible to hold up their incredible mass on those spindly little forearms. Not only that, but you can see the sort of flesh mitten, for lack of a better term, that their hand actually was. Like, not every single one of their digits was a separate finger. Some of them were kind of like contained within the mitten. And that is something that was completely new to science and we didn't really know about. Even for me, I had to modify a lot of older dinosaur art that I had done because I was wrong. And that's the beauty, right? I gotta say, every time that we are proven wrong about assumptions in paleontology, it shakes everybody up to such a degree that, to me, it's like Christmas. Not just because it's shaking people up, but it forces us all to kind of reevaluate all the knowledge that we have built so far and, correct those assumptions so that we can keep moving forward. That's what science does. I'm still just admiring this forearm, like this preserved hand with scales and nails and toe pads and everything. This was recently published as being like the first incidence of actual hooves. And by technicality, these do count as hooves. So it's really cool to see that these duck-billed dinosaurs, like, sorry mammals, stole the thunder. And I'm still super excited about the whole well-preserved hand because it's gotta be, like, I just want to shake his hand. You probably could. It's that beautiful. It's that nice. Seeing the way that its nails are preserved. Like, it's got these fleshy pads that it would support its enormous weight when it decided to go down on all fours. Because the idea still is that Edmontosaurus was a facultative biped, which means that it could be a biped when it wanted to be, but it could be a quadruped when it wanted to be as well. And yes, the skin frill going down the back of Dakota is also even more impressive than the one on AMNH 5060. Maybe it was like an overgrown iguana with, how iguanas have those long scales that stretch out into spikes. Except these ones were short. You just had like a little flat top. Based off of all of this incredible mummified data, I mean, we can make inferences on how it moved, how it carried its weight, how it may have defended itself, how it walked. There's so much to learn from this fossil. It's incredible. I actually have a painting on my wall from one of my favorite artists, Julius Chotany. It's his reconstruction of Dakota, who has, I suppose, recently passed away on the side of a river. And it's peaceful, it's serene, it's beautiful. And I see it and I'm like, Dakota, you are real. Another incredible dinosaur mummy is Leonardo. Leonardo is so well preserved that it holds a Guinness World Record for being the best preserved dinosaur ever found. Around 90% of its skin is preserved, lying tightly against the bones, except for one area on its right shoulder, where 6 centimeters of thick muscle can be seen, which revealed something surprising about its posture. Since its neck base was heavily muscled, it had to have held its head much higher than earlier reconstructions based only on the spine had predicted. Its body was covered in small polygonal scales, with a row of larger triangular scales running along its back that aligned with each vertebra. Leonardo even had a broad keratinous beak on its snout. But the discoveries don't stop at the surface. Within Leonardo's ribcage, scientists discovered the contents of its last meal: ferns and tree leaves. They even found evidence of stomach parasites, tiny needle-like worms covered in fine bristles, fossilized within the dinosaur's remains. Leonardo doesn't just show us what dinosaurs looked like, it showed us how they lived, what they ate, and what died within and along with them. In 2011, a dinosaur mummy of a nodosaur was found in the oil sands of Alberta, Canada. The fossils were found in a mine operated by Suncor Energy, which gave the dinosaur its nickname, the Suncor Nodosaur. This ankylosaur relative was so perfectly preserved that researchers felt like they were staring into the eyes of a living dinosaur. I can corroborate that. I have looked into those eyes, and there's nothing like it. It also feels like staring into the eyes of a giant pine cone, but that's just what they look like. It's pretty cool. He stood 5.5 meters long and was preserved in 3 dimensions, with his armor, skin, and body shape still intact. At his shoulders, a massive 50-centimeter long spike jutted outwards from either side. And along the top and sides of his body were rows of smaller armor plates that were thickest around his neck. The Suncor dinosaur, what an incredible specimen. The fact that you have all of these scutes and, pieces of armor still in position for this dinosaur is such a rare thing in terms of, ankylosaurs and nodosaurs in general. Oftentimes you'll find one of those pieces kind of isolated or scattered about, but the fact that they're all preserved together, it is such an amazing Rosetta Stone of how these dinosaurs come back together. So yeah, it's kind of exemplary of how to reconstruct a nodosaur. I actually used it as reference for quite a few pieces of art myself, so it's beautiful. And I can say that firsthand because I got to go and visit the Suncor dinosaur at the end of a fieldwork season, and it had recently just gone on display and was reassembled and all just so beautiful. Getting to glimpse at this dinosaur frozen in time, it looked like a sleeping dragon. And they really aren't kidding when they say that. It's stunning, and you should definitely owe yourself a little visit to go see the Suncor dinosaur. Borealopelta. Also, what a beautiful name. The fossilized plates showed a keratin sheath with a thin film that allowed scientists to have a glimpse at a nodosaur's coloration. They even found chemical signals that showed it was countershaded. A color pattern where the back of an animal is darker and the underside is lighter. This pattern is common in modern animals because it helps camouflage them from predators. We actually got to talk to one of the researchers who has studied this fossil in depth to give us some insights into the story of this amazing fossil, and to explain why he doesn't think that Borealopelta got dried up before it was buried.
My name is Donald Henderson, and I am curator of dinosaurs here at the Royal Tyrrell Museum of Paleontology in Drumheller, Alberta, Canada. So it's clearly truly a land-living animal. Everything about its skeleton, its anatomy, tells us it was great on land, be terrible in water. And it's also, the dentition says it was clearly a herbivore, plant eater. Somehow it died, and it got into a river, maybe in a flood. It floated downstream in that river, and it got washed out into the Western Interior Seaway, which was a body of shallow seawater that ran all the way at times from Gulf of Mexico up to the Arctic Ocean. It got buried in that body. It was floating out in that area. Eventually, bacterial decay in the gut, we think, must have caused the body to bloat and burst under gas pressure. And it very quickly went to the seabed. And it went to the seabed on its back. It must have gone into water at least 50 meters deep. and a very soft, muddy water, and it was quickly sinking to the bottom of this mud at the bottom. We know the depth because there's a distinctive mineral in the rock layers that host that fossil. It's called glauconite. It's a phosphate mineral, and it only forms in water that's deeper than 50 meters. So we've got a minimum depth of burial. That's really deep. So in the same waters above it, we often get the occasional ichthyosaur, a swimming marine reptile, or a plesiosaur, a long-necked one. They were around. They obviously didn't get to this carcass because they would be the first prime suspects for scavenging and pulling it apart. So it was clearly sealed away. There's very little in the way of trace fossils left by burrowing animals in the muds. So it must have been very low oxygen. So it was this exceptional conditions, quickly buried it away from scavengers and in low oxygen or completely lacking in oxygen that led it to be preserved.
So how does a fossil like this end up in a museum like the Royal Tyrrell?
People usually send us pictures. We're really well equipped here. We've got the vehicles, we've got the tools, we've got the staff, we've got 6 people in our lab. Within about 48 hours of us getting a call, we can usually be on the ground. And that includes driving 800 kilometers north to Fort McMurray in all weathers. Sometimes it's a rather tense drive in the winter. We're on the ground because for these mine people, time is money for them. They want to get it out of the way, and we want to get it before any damage happens. So we usually have an idea before we go of what it is, because we know the geology, we know the rock types, we know the ages, we know what sort of things to expect. And we've got all our tools. We've done so many of these things now. It's almost cookbook. But every specimen is a little bit different because of the physical situation or what it is and how it's laid out. We can usually be done in about 5 days. That Borealopelta thing took us 17 days. Because it was a very different situation because you're in this massive industrial complex and there's all these people, hundreds and hundreds of people working there every day. And it was quite a logistic effort to get that one out. Quite different from some of the other smaller ones we do. But the mine people loved it. They bent over backwards to help us. It worked out really well. We had a few problems because it was unusual rock and unusual fossil, so it took much longer than we thought.
Dinosaur mummies like the Suncor Nodosaur are incredible specimens, but they're also extremely rare. So scientists rely on other methods to figure out what dinosaurs looked like. One of the biggest breakthroughs came from studying the fossils of an Anchiornis, a small four-winged paravian dinosaur from the late Jurassic period in China in 2010. These fossils preserved actual feathers, including microscopic pigment structures called melanosomes. By studying their shape and arrangement, scientists can reconstruct the original colors. Anchiornis had black, white, and gray body feathers, with dark dotted strips on its outer wing and speckles on its inner wing. It even had a striking dark red crest on its head and brown speckles on its face. Anchiornis was literally a redhead. Another Anchiornis specimen was studied in 2015, which showed the same body feather patterns, but no red crest. This specimen was smaller though, and may have been a juvenile that had not grown out its red crest yet, like how juvenile sandhill cranes lack their red crown. Sometimes the pattern on feathered dinosaurs can be revealed too, like Sinosauropteryx, a small theropod from the Cretaceous period with an unusually long tail and small arms. Its tail looked like a raccoon's tail, with alternating bands of light and dark feathers. It also had countershading. Researchers suggest that the dark back, light stomach, and banded tail were used as camouflage against the brush. Scientists have even figured out that the Microraptor, a small four-winged dromaeosaurid from the early Cretaceous period, had iridescent feathers that shimmered in the light, kind of like the glossy feathers you see on European starlings or even hummingbirds. To figure that out, they used something called a scanning electron microscope. Instead of using light, it scans an object with a beam of electrons to reveal super tiny surface details. When researchers zoomed in on the fossilized feathers of the Microraptor, they found the rod-shaped melanosomes stacked in neat layers, exactly like the ones found in the shiny black feathers of starlings. Scientists also use digital modeling and comparisons with living animals to determine how dinosaurs looked. By studying muscle attachment points on fossilized bones and comparing them with birds and reptiles, researchers can estimate muscle mass, body posture, fat deposits, and even movement patterns. In 2021, researchers from the Royal Veterinary College and the Museum für Naturkunde, Berlin, took this concept even further. They scanned fossilized archosaur bones to create 3D digital skeletons and compared them to living animals like guinea fowl and juvenile alligators. They created simulations and models to test how the dinosaurs walked, and found that dinosaurs moved more like humans than birds. Most dinosaurs didn't move like modern birds, with their crouched posture and knee-driven motion. Instead, they stood more upright, with hip-driven motion like that of alligators and humans. When these digital models are combined with fossil evidence, like dinosaur mummies and skin impressions, we get reconstructions that are far more realistic than ever before. And with modern technology, that picture is only getting clearer. New technologies are allowing scientists to analyze dinosaur remains in ways that were impossible just a decade ago. Synchrotron imaging uses incredibly powerful X-rays to scan fossils, revealing microscopic structures inside the rock without damaging the specimen. With this technology, scientists can see details of embryos inside fossilized dinosaur eggs, like that of Massospondylus carinatus, which roamed the Earth 200 million years ago in South Africa. Researchers use synchrotron imaging to create highly detailed images of embryos inside the eggs. The embryos had two types of teeth. One set consisted of simple triangular teeth that might have been resorbed before hatching, just like in modern-day geckos and crocodiles. The researchers also compared the skulls of the embryos to those of their modern relatives, and determined that the embryos had only gone through 60% of their development before they were buried and fossilized. Another way we can get a glimpse of how dinosaurs looked is by using advanced chemical analysis techniques that can detect biomolecules that have survived fossilization. In some rare cases, scientists have identified fragments of original proteins preserved in dinosaur fossils. In 2025, scientists found remnants of collagen in the hip bones of an Edmontosaurus, the same type of dinosaur as the AMNH mummy. To confirm that organic material was still there, scientists used a mix of lab techniques like mass spectrometry, protein sequencing, and cross-polarized light microscopy. One of the most important tools was tandem mass spectrometry, which is basically a molecular detector. It allowed them to spot hydroxyproline, an amino acid that's linked to the collagen you find in bones. What makes this discovery so exciting is that it shows organic materials found in fossils aren't always just contamination, but we're still trying to figure out how much of it is actually biomolecules. It also means that other fossils sitting in museum collections could be hiding biochemical clues, just waiting for scientists to look a little closer with newer technology. We haven't even mentioned the Cloaca Mummy. There's a dinosaur whose butt was preserved. The fossil that revealed what the rear end of some dinos looked like is SMFR 4970. It has what researchers have described as an exquisitely preserved cloaca. The opening belonged to a Psittacosaurus that roamed China around 120 million years ago. It's unclear how it died, but the way its body was positioned meant the cloaca was clearly visible. After it was buried and fossilized, it preserved details we'd never seen before. The cloaca looked like a crocs, but had fleshy parts that gave it a V shape. The fossil was also unique in showing us that some dinos had belly buttons. It sounds weird for an oviparous animal to have one, but embryos inside the egg are connected to their food source, the yolk sac, through a cord. And when that connection closes, it can leave a small scar that we'd recognize as a belly button. Weird! And yet, despite giving us this amazing detail, we mostly know this fossil because it died in such a revealing pose that we're still talking about its cloaca 120 million years ago. But hey, it's still a super valuable discovery that's giving us unique insights into what these dinosaurs looked like. And discoveries like this raise the possibility that one day we may understand dinosaur biology in unprecedented detail, and every new dinosaur mummy adds another piece to that puzzle.
And as technologies advance, we'll get even more detail. But some of those technologies are still a few years away.
We've done what we can do with chemical analysis and mechanical analysis. My great hope is that CT scanning technology will improve and we can finally see the skeleton, because it's actually kind of difficult to compare our armored dinosaur, a nodosaur, to other nodosaurs from rocks of the same age, but elsewhere in North America or in Asia. They're only known from their skeletons and maybe a little bit of armor. But us, we can't see the skeleton. We have no idea. It's kind of tricky. We would do good old-fashioned 19th century paleontology, comparing bone shapes and proportions and how are they articulated, although we've got more modern knowledge about how skeletons grow and develop. But it would just be comparing the bones and their shapes and proportions. Yeah, that it would just be good old-fashioned paleontology. But instead of doing it physically handling the bones, we would produce tomographic scans, and from that, we would extract 3D data and we could look at virtual reconstructions of the skeletons. The trouble is, the mineralization of the sediment around the fossil is almost the same as the mineralization in the skeleton. And these geophysical or X-ray techniques, or ultrasound, whatever, they rely on density contrast. So the sound waves, the energy waves are passing through and they get reflected and refracted at different interfaces between different materials. And if you don't have that contrast in density, you don't get a reflection, you don't get a refraction, you don't get a signal. It looks totally opaque or totally uniform. If you remember the first Jurassic Park film, they were using that the sound waves and stuff. That's so bogus. The sound waves would just pass right through the rock and the fossil and not even notice. And the wavelengths are really long, like at least meters. You're not going to see a skeleton that's less than a meter long. But the technology, it'll come.
Thank you, Dr. Henderson. It's truly an honor to have you on our show.
Each fossil tells us something about skin textures, body shapes, color patterns, behavior, and even diet. For more than 100 years, dinosaurs were mostly skeletons in museum halls. But now, thanks to these extraordinary fossils, we're starting to see them as real animals again. The more we discover, the clearer the picture becomes. And somewhere out there, buried in rock that hasn't yet been explored, there may be another dinosaur mummy waiting to be found. One that could completely change how we imagine the prehistoric world. Because the truth is, we're still learning what dinosaurs actually looked like. And the next discovery could rewrite everything. If you enjoyed this deep dive into dinosaur mummies and the science behind them, make sure to subscribe for more videos exploring the incredible discoveries changing how we understand prehistoric life. What should we talk about next? Drop your questions in the comments below. Thanks for watching. See ya!